Hello everybody, I'm going to show you how to factor perfect cubes, okay? So to do this, I'm going to start off with a couple of multiplications, a plus b times a squared minus ab plus b squared, and then I'm going to do a similar thing with a minus b and then a squared plus ab plus b squared. Okay, so I'm going to set up my box so that I can do this, and it's a 2 by 3. So I'm going to set this up for both of these just to go ahead and get them out of the way. Now I'm going to label my dimensions. So I have a plus b, and then I have a squared minus ab plus b squared. All right, so when I look at this, what I'm going to do is I'm going to first multiply length and width. So a times a squared will give me a cubed. Then I take a times negative ab, add the exponents on the a's, negative a squared b. Then you take a times b squared, positive ab squared. Then I go to the b down here, and I multiply that to everything. So b times a squared, I'm going to write that as a squared b. B times negative ab, I have negative a b squared. Again, add those exponents on the b's. And then b times b squared will give me plus b cubed. So let's see what we notice here. So I notice that my first term is just a cubed. Then I notice I've got some canceling a squared b's and some canceling ab squares. So those are all gone, leaving me with just plus b cubed. Okay. All right, let's see what happens when we do the other one. So we have a minus b, and we have a squared plus ab plus b squared. All right, so just as we did before, we're going to multiply. A times a squared gives me a cubed. A times ab is a squared b. A times b squared is ab squared. Then we go to the minus b and distribute that. So negative b times a squared is negative a squared b. Negative b times ab would be negative ab squared. And then negative b times b squared would be negative b cubed. All right, so again, I notice I start with a cubed, but then I see some canceling a squared b's and some canceling ab squares. So all that's left is minus b cubed. All right, so what do we notice about the answers we got? Well, in both cases, we had a binomial, only two terms. And if you look at those terms, they were both raised to the power of 3. So they are what we're going to call perfect cubes. Okay. All right, so this is actually what we're going to do to factor. So when we factor perfect cubes, we're going to go from something that's written as perfect cubes to something in factored form that looks like these things. Okay? So to do this efficiently, we're going to need some perfect cubes. So what we're going to do is list the first 10 perfect cubes. So 1 cubed is 1 times 1 times 1, so just 1. 2 cubed, 2 times 2 times 2 is 8. 3 cubed, 27. 4 cubed, 64. 5 cubed, 125. 6 cubed, if you don't know that, you can go to a calculator. 6 times 6 times 6 gives me 216. 7 cubed, I can never remember this one off the top of my head. 343. 8 cubed, I think is 512, but I'm going to just double check. Yep, 512. 9 cubed, 9 times 9 times 9, 729. And 10 cubed, we all should know is 1,000. Okay. So now that we have our perfect cubes, this list right here is going to be important because if you have this list memorized, then your life is going to be that much easier when you factor these. Okay? All right, so let's talk about how to factor. First, we want to make sure that we remove any GCFs if we have them. And actually, I'm not going to do this equation. We're just going to do w cubed minus 8. Okay? We want to check to see if it's perfect cubes. So if it is, then we can use this pattern. W cubed minus 8. What this means is that, so this is W to the power of 3, and this 8 was 2 to the power of 3. So they are perfect cubes, and we have a minus sign in between. So that means that it is indeed something that will factor this way. All right, so now for the patterns, here's how we're going to do this. So if you have something cubed plus something cubed, the first factor will always be the A plus the B. Okay, so you identify your A and your B that are being cubed, and that'll be your first factor. Notice that the sign in the original problem is the same sign as the sign in the first factor. Okay. Then we're going to have a slightly longer factor where we're going to take the A and square it. So it goes A squared. Now I need the opposite sign. So if this is a plus, this sign will be the opposite. Actually, let me put that over here. And then I take A times B, so AB. And then the last sign is always positive. Okay? And then we take our B and we square it, and that goes here. By the way, when I spelled out the S, the O, and the AP, that is a way that can help you remember the signs. I always tell students to remember to use SOAP. Okay? Now the other factor where you have a minus sign between your perfect cubes is going to look more like this. So you're going to have your A value minus your B value. Again, notice that these signs are the same. Then we're going to have A squared plus AB, plus because now we have the opposite sign. And then this sign right here is always positive, just like it was in the last one. And you square the B. Okay? All right, so now that we have the patterns here, let's go ahead and apply that to this problem. Okay, so my A is W, and my B is 2. I have a minus sign between the problems, so I need to use the second formula. So I'm going to have A minus B, so in this case, W minus 2. Then I'm going to take my W and I'm going to square it, so W squared. Opposite sign, so plus, and then I take my A times my B, so 2 times W. Always positive sign after that, and then I take my B and square it, which will be 4. And this is how it's going to factor. And the quadratic here, the W squared plus 2W plus 4, will not factor. There is no set of numbers that can multiply to 4 and add to 2. All right. Now let's try a couple more examples. Okay, on example 2, first of all, let's note that both of these numbers can be divided by 2 and x. Okay, and then that will give me 125x cubed plus, I think, 64. Now I have to then identify my a and my b. So if I look here, what did I cube to get 125x cubed? Well, that would be 5x. If you go back to your list of cubes, 125, you got it by doing 5 cubed. For 64, again, go to that list of cubes. You would have had 4 cubed. So this is going to be our A and our B. So when I factor this, I'm going to do a short factor and a long factor. I'm going to take my A, which is 5x, I have a plus sign in the problem, so I'm going to keep the same sign in the first factor. And then my b is 4. Okay. All right, now I'm going to go ahead and fill in the signs for the next part, so I know I need the opposite sign here, and this will always be positive. All right, when I do my a and I square it, 5x squared is the same as 5x times 5x, which will be 25x squared. Okay, then I take 5x times 4 and I get 20x. And then I take 4 squared and I get 16. All right, now remember that 2x that we had from the beginning? Make sure you put that along with your final answer. Okay, there's our answer. All right, next one here. You could do this a couple of ways. You might notice that the 216 is a perfect cubed. It's the same as 6 cubed. And 27u cubed is the same as 3u cubed. What's going to happen though is that you're going to have your first factor will be 6 minus 3u. And then for your bigger factor, you're going to take your 6 and square it to get 36. Opposite sign, 6 times 3u would be 18u. Always positive sign. And then 3u squared is the same as 3u times 3u, which is going to be 9u squared. Okay? I made that a little bit too long there. Now, you might be thinking, okay, well, that's not bad, except if you look at the first group here, there is a common GCF of 3. And if you look at all 3 of these terms here, there is a GCF of 9. So we're going to take that 3 and that 9, they're going to come out of those factors, and then we're going to find out what's left over. 6 minus 3u divided by 3 gives me 2 minus u. And when I take the 36 plus 18u plus 9u squared and divide all those by 9, I get 4 plus 2u plus u squared. So my final answer here will be 27 times 2 minus u times 4 plus 2u plus u squared. Okay, so this is an example of one where you actually had a GCF at the beginning, but if you didn't know that there was a GCF, you could have gotten it after you did some factoring. Just depends on the problem. All right, example 4 is the last one that I'm going to do because I probably won't have enough video to be able to do this. If we look at this, right now this is a difference of squares. So if you're an 8A student, you've already learned to factor this as you take the square root of each of those terms. So you'd have x cubed minus 1, and you'd have x cubed plus 1. If you haven't had the difference of squares lesson yet, you'll learn this, but just note that this is how it'll start to factor. Now each one of these is perfect cubes. So we're going to have a short factor and a long factor. This one will also have a short factor and a long factor. X cubed gives me an a of x. 1 cubed is 1. Keep the same sign. Now we're going to take our x and square it. So x squared, opposite sign. 1 times x is just x. Always positive sign. 1 squared is 1. So x cubed minus 1 will factor like this. I'll use purple to do the other one. This one will be x plus 1, and then we have x squared minus x plus 1. Okay, that's the other factor. So for my final result, well, I would just put all this together. Okay, and this is what the factored form would look like. Okay, sometimes people might write it as x minus 1, x plus 1, and then they put their quadratic ones. Okay. I don't really care how it looks.